Question number 1. A client with cardiogenic shock weighs 220 pounds and is receiving dopamine at a rate of 3 micrograms per kilogram per minute. The solution strength available is dopamine 400 milligrams and 250 milliliters of D5W. The nurse should set the infusion pump to deliver how many milliliters per hour? Please ignore the writing. We will work this problem using ratio and proportion first. The first step is to write what we have given. We have 3 micrograms per kilogram per minute. When we write this, we can recognize that this is also equivalent to this. 3 micrograms divided by kilograms divided by minutes. But when we look at this, it is the same as taking the numerator, or what's on top, and dividing it by minutes. It equals to 3 micrograms per divided by kilograms divided by minutes. But when we understand what division actually is, division is when you multiply by the reciprocal. And so we change the division to multiplication, and then the reciprocal is just taking whatever you see and writing the top on the bottom and the bottom on the top. In this case, we had a 1, and so now we can write minutes here. Now we could have done this another way. We could have divided the 3 micrograms by kilogram minutes. And as you can see, we take the division, change it to multiplication, and we flip, we write the top on the bottom and the bottom on the top, and we end up with 3 micrograms over 1 times milligrams a minute. Now what you see here is for even for both of these problems, for this one and this one, whenever you're multiplying fractions, you multiply the numerator times the numerator, which is the number on top, and the item on top, and the denominator times the denominator, which is the item on bottom. This will give us 3 micrograms times 1 over kilograms times minutes. So we get the same thing, 3 micrograms times 1 . What we actually see is that we come out with something different. What the convention is, if you have something stacked, the first 2 numbers will be the numerator, and then the second number or 2 numbers, this will be over 1, will be the denominator. So keep that in mind so you don't end up with the wrong thing. This would have been 3 micrograms times minutes over kilograms. Okay, so what we've got to do first is convert this 3 micrograms into milligrams. So we're going to set up a ratio and proportion to do this. First, we'll rewrite this the way we just explained. So now we're going to take this 3 micrograms and convert it to milligrams. Okay, we'll set up our proportion here. So we have 3 micrograms compared to X milligrams equals 1,000 micrograms compared to or in 1 milligram. We then cross multiply. Now, when you see the equal sign, it tells you to cross multiply. But if you don't see that, you see a multiplication sign or division or a multiplication sign in there, you have to multiply the numerator times the numerator and the denominator times the denominator, as we said earlier. So after we cross multiply, this is what we get. 3 micrograms times 1 milligram equal 1,000 micrograms times x milligrams. And then we're going to divide both sides by 1,000 micrograms. And so the 1,000 micrograms cancels out here, leaving us with the right units, x milligrams, on the right side. And then the micrograms cancels out on this side, leaving us with 3 times 1 over 1,000 milligrams, which is the right unit on the left side. Well, we know that this top part with the 3 is just 3, and that's 3 divided by 1,000. So that gives us 0.003 milligrams. So we have, again, that x, which is in milligrams, is equal to 0.003 milligrams. So we have 0.003 milligrams over kilogram times minute, and we just converted that. Now we need to get the total milligrams per minute. We can do that by understanding that this can be rewritten as 0.003 milligrams per minute. Okay, because when you're dividing by something and then dividing by it again, that means you can divide the first one by the second one, and then divide the second one as follows. Okay, so what we did was we just rewrote this milligrams per kilogram per minute, because it doesn't matter if you put the minute on this side and then kilograms like that. And then because milligrams over kilogram or milligrams over a minute kilogram is the same as saying milligrams per minute per kilogram. Okay, so what we're saying is milligrams per minute per kilogram. And so that's how we're setting up this proportion. So we've got 0.003 milligrams per minute over 1 kilogram, there should be a 1 there, equals x milligrams per minute over the same type of unit, which is a mass, but this time they're not in the same units as given in the problem. So what we need to do is convert this 220 pounds into kilograms. And so we set up a proportion to do that first. So I'll do that right here. Okay, it's 220 pounds over x kilograms equals 2.2 pounds over 1 kilogram. And we solve it, we cross multiply. And so we get 220 pounds times 1 kilogram equals 2.2 pounds times x kilograms. And we divide both sides by the 2.2 pounds. And that gives us 220 pounds times 1 kilogram over 2.2 pounds on the left, and 2.2 pounds times x kilograms divided by 2.2 pounds on the right. When we cancel this out, we're left with x kilograms, which is the right unit in kilograms. And when we divide on the other side, we cancel out our unit, which is pounds, and we're left with kilograms, which is the right unit or the correct unit on the left side. And when we reduce this, we get, when we divide 220 by 2.2, we get 100 kilograms, because that 1 is multiplied by 100, it still is 100. 100 kilograms equals X, and X we know is in kilograms. Okay, so now we can take this 100 kilograms and replace the 220 pounds in this proportion that we were trying to find. And once this is done, we can, and there should be a decimal right here. Once this is done, we can cross multiply. We cross multiply, and this is what we get. 0.003 milligrams per minute times 1,000 kilograms is equal to X milligrams per minute times 1 kilogram. And what we do is we divide both sides by the 1 kilogram in order to get X by itself. And to simplify things, let us understand that division is the same as multiplying by the reciprocal. So I'm going to divide both sides by 1 kilogram, but instead I'm going to multiply by the reciprocal like this. And so when I multiply by the reciprocal, the 1 kilogram cancels out with the 1 kilogram, and that leaves me with X milligrams per minute on the right. And then I have 0.003 milligrams per minute, and the kilograms cancels out on the left, and this is just 1 over 1, so that's just 1. And so I take my two numbers, 0.003 and 100, multiply them together, and I'm left with the correct units, milligrams per minute, as such. So I just put the two numbers in parentheses to show that they're multiplied together. And you are left with the answer of 0.3 milligrams per minute. Okay, so 0.3 milligrams per minute equals X, and we know that X is in milligrams per minute. Okay, next we need to change this milligrams per minute into milligrams per hour. And so we set up a proportion like this. And just before I set up that proportion, I'm just showing you our progression so far. We went from 3 micrograms per kilogram times minute to 0.003 milligrams per kilogram times minute to now it's 0.3, and that should be, sorry, I wrote hour, that should be 0.3 milligrams per minute. And so now in order to change this to milligrams per hour, we are going to set up a proportion here. So we have 0.3 milligrams in 1 minute equals X milligrams per hour. So we first need to figure out how to get our units the same on the bottom. So what we'll do is we'll convert 1 minute into hours. So we know that 60 minutes equal 1 hour. So if I divide both sides by 60, then I'm left with 1 on this side and 1 hour compared to 60 minutes on this side. So we know that another way of looking at this is to say that 1 minute, and in fact, I should have done it like this, divided just by 60. And so it equals 1 times minute, or 1 minute, which is the unit that's left, equals 1 over 60 of an hour. And so basically we know that 1 minute is 1/60th of an hour. Again, I just divided both sides by 60, and my unit is 1 minute, so I have 1, which is 60 over 60, minute equals 1 over 60, because I divided both sides by 60, and my unit is hour. So 1 minute equals 1/60th of an hour. I can now bring this back and then change my units to hours, like so. So now I have 0.3 milligrams over 1/60th of an hour equals X milligrams over hour. Okay, I'm going to cross multiply, and that gives me this right here. So I get 0.3 milligrams times 1 hour equals X milligrams times 1 over 60 of an hour. And it should have been a 1 right here. And so what happens is I can divide both sides by 1 over 60 of an hour, so I can get my X by itself. Okay. But it's simpler to just multiply by the reciprocal, because division is multiplying by the reciprocal, which is multiplying by this flipped over. So let's flip this over right here. 1, now that hour is up there with the 1 over 60. So when I flip it and find the reciprocal, which I represent by a big R in a circle, then I'm going to have 60 over 1 hour. So I can change this one and multiply by 60 over 1 hour. And, you know, I'm recognizing that this is 1 hour, you know, 1 over the top, 1/60th of an hour. Well, that means the 1 times hour over 60. And I just cancel out everything on this side. Okay, because the top can cancel out with the bottom. Well, I do the same thing on the other side. And so I have 0, and that should have been 0.3 milligrams earlier, 0.3 milligrams. And so this 1 hour and this 1 hour cancels out, and this 60 oh, I'm sorry, there shouldn't be a 60 up here. Let me get this straight. Okay, now it's correct. 0.3 times 1 hour times this reciprocal over here, 60 over 1 hour. And we cancel this part out. And we're left multiplying 0.3 milligrams times 60. And it gives us X, because all this is gone. So it just gives us X milligrams. And we have the right unit on the left side, milligrams. So 0.3 times 60 is 18 milligrams equals X. Now, So basically, what we did was just replace the bottom with hour, and then the top has to change to 18 milligrams in an hour because we have zero point 0.3 milligrams in a minute. If we multiply that 60 times, we get 18 milligrams in an hour. And so now we need to figure out how many milliliters that is per hour. So that's what we're trying to do now. We're trying to figure out how many milliliters this is in 1 hour. So we set up our proportion like this: 18 milligrams over X milliliters equals 400 milligrams over 250 milliliters. And the reason why we can set that proportion up is because what we're doing is we're saying when we slice this large amount up right here in equal parts, it's going to be 18 milligrams. Well, I want to know, since I'm slicing the 400 milligrams up into equal parts, that means the amount of medicine that the 400 milligrams is in, which is the 250 milliliters, is also sliced up into equal parts. And that's what I want to find, X. So I can set that proportion up. 18 milligrams is compared to X milliliters. It's the same ratio as 400 milligrams to 250 milliliters. And I can solve that proportion here. So I have 18, when I cross multiply, after I cross multiply, I get 18 milligrams times 250 milliliters equals 400 milligrams times X milliliters. And then when I divide both sides by the 400 milligrams, I get this to cancel out on the right side, leaving me with X milliliters, which is what I'm looking for. And then the milligrams cancel out, and I just multiply 18 times 250 and then divide it by the 400. So 18 times 250 over 400 milliliters, that's my answer, that's what I have left over, equals X milliliters. So that answer is 11.25 milliliters. When we go, I put the answer up here. 18 times 250 over 400 equals 11.25. And so our answer is 11.25 milliliters per hour. And that is our answer. And this is our plan. We went from 3 micrograms per kilogram minute to 0.003 milligrams per kilogram minute to 0.3 milligrams per minute to 18 milligrams per hour to 11.25 milliliters per hour. And that's how you work question number 1 with ratio and proportion.